Hello again, geometry students. Welcome to True and False, everybody's favorite questions to answer. Very easy to outthink yourself on true-false questions. Cannot really infer anything into them. They are what they are. And so a figure and its image and a rotation are congruent. You will recall that is true, and the reason it is true is you have transformations, and quickly sketch out that hierarchy chart for you. And then of those you have some that are isometries, and they preserve distance and angle measure, in other words congruence. And there were four types of those transformations. You had a reflection, you had rotation, and you had translation, and then after we got into 8-3 we learned about glide reflections. Alright, so if this statement that we had for our first true false is actually true of all of these that I have listed so far, that they are all congruent under whatever the isometry is that they're using. And remember, we had this other one over here, dilation, which is its own animal, and does not preserve distance and angle measure, at least not distance. Alright, all isometries are transformations. Well, you can see from the chart that yes, that's true. See how all the isometries fall under the transformation label. The reflection of any point is a different point. Now at first look, that might be one that we would say, well, obviously it's got to be a different point. How could it not be? Here's how it could not be. Let's say this is your reflecting line. Okay, and let's say that you've got a segment that has a point there, and a point here, and call this A and this B. Alright, so if I reflect that across, this would be the same distance across B prime. Well, where does A reflect to? It's right on the reflecting line. So here's an exception to that. All I need is to find one counterexample, and that makes the whole statement false. So the reflection of any point is a different point. False. I found one example here in which that is not the case. A and A prime are the same point because they are right on the reflecting line. Don't get fooled by that one. D, a dilation is a transformation that preserves distance and angle measure. I'll see how this chart helps us. I mean, if we know that isometries preserve distance and angle measure, and we see that the dilation is not an isometry, then we can easily see that that's false. Every rhombus has reflection symmetry. True. Those four equal sides give it reflection symmetry. Alright, that's true and false. Don't outthink yourself on that. Good luck, and see you on the next one.